This is Lakshmi. In today's session, I am going to discuss about stoichiometric calculations. Most of the students are feeling little tricky, little bit difficulty while solving stoichiometric calculations. Why? Because standard conditions. If we are remembering standard conditions, then according to the numerical stoichiometric calculations feels very comfortable and easy. But how to connect questions after knowing the standard conditions, how to apply? So 4 to 5 numericals I am going to explain, students. Before going to the numerical, let me discuss some reactions which is frequently asking in examination. Stoichiometry, or some of the students they will call it as stoichiometry also, and mole concept, basic principles in chemistry. This is one of the topics. Stoichiometry. Okay. Now here stoichiometry chapter, so frequently asking some reactions. That reactions also we can discuss. SOTOI, stoichiometry. Okay, I am giving some equations. Those equations we can list out first. Calcium carbonate on decomposition. Calcium carbonate on decomposition. What you will get? Calcium oxide plus carbon dioxide. You have to write names also. Sometimes they will give names. This is carbon dioxide gas, we all know. Next, this is one of the questions. And students, one more point. Stoichiometry is nothing but in balanced equation. First step, we have to balance the reaction. And second step, what is the number before the compound? What is the number before the compound? That is nothing but number before the compound, or before the molecule, before the compound, is called stoichiometric coefficient or stoichiometric coefficient. If suppose there is no number, then you can take it as 1. Here 1, this is also 1, this is also 1, like that. Okay, see here 1 calcium atom, Here 3 oxygens, 1 carbon, balanced. After balance the equations only we have to express the stoichiometric coefficient. Clear? Now next, one more important one. KClO3. This is potassium chlorate on decomposition. This is also decomposition, thermal decomposition. We will get KCl plus O2. You have to balance this reaction. So here you can take it as 2. This is also 2. See, 2 potassium. Chlorine, 2 chlorine. 2 3s are 6 oxygens. Yes, here we have to balance. 3 2s are 6 oxygens. This is gaseous state. This is potassium chloride. Okay. They may or may not give in examination. So in competitive exams, NEET and mains exam, they are not giving required equations many times. And starting exams time, sometimes they will give, but most of the times they are not giving. Now, next another one, all hydrocarbons. One important note point I am writing, students. All hydrocarbons on combustion gives products are same, CO2 and water, carbon dioxide and water. Okay, but all hydrocarbons giving the same product. No, but how you know, how you can show the difference in the reaction? We have to balance the carbons, right? So first point. Second point, we have to balance in systematic way. First carbon you can balance, then hydrogens you can balance, then oxygens you can balance. Then your answer will be perfect. So now let me write. So common hydrocarbons, tell me students, you people know what is this first one? Methane, right? Second one, ethane, C2H6. If 2 carbons is there, we are using the root word ethane. Next, ethene, just 2 hydrogens less. This is ethene. Next, ethyl, C2H2. So these are all hydrocarbons. See, hydrocarbons is nothing but only carbon and hydrogen. Only hydrogen, carbon. That's it. Those compounds. Even benzene also. Benzene also same thing, no? So these are all you can write. I will give you here 3 examples, students. So afterwards you can work out remaining questions. Okay. See the first one, students, methane. This is one of the frequently asking question. Methane on combustion. Who will support combustion? Oxygen, right? CO2 plus water, right? So now see, this is in gaseous state, this is in gaseous state, physical state also plays important role. It is in liquid state, gaseous state. Okay, now see students, here carbons balanced, hydrogens here 4 balanced hydrogens, 2 twos are 4, right? So oxygens first you have to count always right hand side, Oxygens you have to calculate first right hand side, then you go for give left hand side, then left hand side LHS. Okay, see here 2, here 2, 4, 2 twos are, that's it, you can balance. Next, suppose we have taken C2H6, ethane. Ethane on combustion. So this is what? Methane. Next, what you will get, students? CO2 and water, right? CO2 and water. Here 2 carbons, right? And how many hydrogen? 6. 3 twos are 6. 2 twos are 4. 4 plus 3, 7. 7 by 2. Here you will get fractional value also, no problem. Listen carefully this point. Here only most of the students is confusing. Here 7 oxygen atom, atomic state, it is in atomic state, but this side molecular state. That is why I have done 7 by 2 O2. Then these two get cancelled and then finally we'll get 7 oxygen atoms. So why to take like this, madam? We'll take here 2 moles and we can balance, no. But here standard conditions is nothing but, students, we are taking for only 1 mole. Standard conditions is nothing but, STP conditions is nothing but standard temperature and pressure. We are speaking for always 1 mole. That's why you have to take it 1 mole only. If you will get fractional value, whereas in case of oxygen also nothing will happen. Okay. Now next one, remaining examples we can work out. Next one, benzene. Benzene on combustion gives CO2 and water. Clear, students? Here also same thing. So 6 carbons, right? So 3 twos are 6. So 6 twos are 12. 12 plus 3, 15 by 2, right? That's it. You have to balance. Next, last one, C2H2, ethylene. Ethylene are also called it as acetylene gas. This acetylene gas plays important role coloring the fruits, ripening of fruits. Market vendors, they will carry carbide packets. Whenever carbide little you can take and add little, after taking carbide, some pinch of small amount, after that you can add water, immediately it liberates acetylene gas. That acetylene gas only giving fruits color, especially mangoes and bananas. So that's why sometimes in markets, so they will give carbide free mangoes, like that also they will announce, right? So this is C2H2 calcium hydroxide. So this is important one. Clear. This one now I am doing combustion. So same story, CO2 plus water. Clear, students? So how many moles here? Here 2, right? So this is what 2 hydrogens. Here 2 hydrogens balanced. Oxygen 2 twos are 4. 4 plus 1, 5. 5 by 2. That's it, students. Okay. So like this we can work out the combustion reactions. Now we can start. Previous year questions too I have collected, students. Previous year questions we can work out. As of now, are you able to solve these questions or not? Check. Okay, everyone is little confusing, but after done some questions, definitely you can feel it is very comfortable. Okay, so note down one question, students. Number of moles of hydrogen molecules. Okay. Number of moles of hydrogen molecules. Okay, 1 second, students. Better I will write one more also. Then I'll come back to the numerical. So why? Because students confusing standard conditions. Those standard conditions also let me complete first. STP conditions or NTP conditions. Standard temperature and pressure and normal temperature and pressure. Standard temperature and pressure and normal or normal temperature and pressure. Both are same. Both are same. Now, let me express some questions. Suppose we will take one question. N2 plus 3H2 gives rise to 2 moles of NH3. It is a reversible reaction. Okay, it is in gaseous state. It is in gaseous state. Physical state also plays important role. Now, this question you have to express in different ways. Okay. So first, known points I will write. Right, students. See, if you will stoichiometric coefficients. So this is balanced equation. Here 1 mole. This is no number means 1 mole. No? 1 mole of N2 combines with how many moles? 3 moles of H2. And how many moles here? 2 moles of ammonia produced. Right? If we are talking in terms of moles. Suppose if you are talking in terms of weight, how to take molecular weight? Nitrogen molecular weight is 28 grams. Here also some of the students are confusing. So end of this video I will give how to identify atomic weights and molecular weights. Don't worry. 28 grams of N2 mixed with 3 into 2, that is 6 grams of H2. Okay, so finally it gives 2 into 17 grams, that is nothing but 34 grams of NH3 produced. This is in terms of weight. Suppose in terms of molar volumes you are expressing. How to express? See, 1 mole of any gas, let me write your points. 1 mole of any gas occupies 22.4 liter volume or 22.4 dm cube also can express, or else 22,400 ml, that is centimeter cube also can express. Here dm cube or else centimeter cube, your wish. Okay, next one, temperature 273 Kelvin. And pressure 1 atmospheric pressure. These are standard conditions. If you know standard conditions, then numerical part is easy. This is 1 mole. No? 1 mole means how much volume, students? 22.4. Irrespective of gas, any gas, no problem. It is 1 mole or not. That's it. This is 3 into 22.4. This is 2 into 22.4 gas. That's it. So liters. If they asked in ml, your wish, you can take it. 22,400 ml reacting with 3 into 22,400 ml, that will give 2 into 22,400 ml of NH3. Clear, students? Clear? Next, one more point. Avogadro number.